Okay, so I'm going to show you how to do one of these problems with kinetic energy theorem. Okay, a little closer. And this is kind of a familiar equation here, and it's one that says work equals the change in kinetic energy. And if you remember, this kinetic energy is equal to 1/2 mass velocity squared. This is energy in motion. We kind of practiced before with those equations. They're kind of simple. And then what we're saying here is the change in kinetic energy. So we have a certain amount we start off with, we call that initial, and then we have a certain amount we end up with, which is final. Sometimes final is greater if it's increasing in speed. Sometimes final is less if it's decreasing in speed. It really just depends on the problem. Okay, so if we keep going with this, we can rewrite this equation. We won't write work again. But we can put in for the change in kinetic energy 1/2 mass velocity squared final minus 1/2 mass velocity squared initial. That's going to give us our change in kinetic energy. If we then look at this though, we have work, and that's fine, but this problem here says 920 kilogram car moves 150 meters, which is a distance, while increasing its speed and get all that. It wants to know a force. So if there's not a force in here, what we then have to do is remember that originally the easier equation is work equals force times distance. So then we take this force times distance, we substitute it for W, we cancel that. So then we end up with the equation force times distance equals 1/2 mass velocity squared final, and so on, right? So then we have a force and a distance, and we can use the numbers that we have. So then if we plug in the numbers, we could then say force times, we don't have a force, we want to know what that was. Well, we do have a distance, 150 meters. We plug in for the velocity, for the final kinetic energy. But if we see we have a 0 here I put in, because we should realize it starts from stop, which is a 0 velocity, and we're going to multiply that 0 through, so in the end there was no kinetic energy because it was stopped, so we can just put a 0 in there. We then do the math, okay, and we would see we'd end up with force times 150 equals 287,500. But then we got to get force by itself, so we divide both sides by 150. And we're going to get an answer like force equals 1,916.6. It's repeating. We could either just put the decimal in, or we could put in 1,917 newtons, whatever we prefer, whatever is called for on the test or whatever the problem that we're doing. So that's one example there. This is where it wants to know force. If I show you the other one, so we can also solve not only for force, but we can solve for distance as well. So here's our other example. This one here says a car with a mass of, same, we always got to have that mass, has its velocity increased from a stopped position. So here, this time, initial is going to be 0 again, to a velocity of 20 meters per second with a force. This time we have a force, and it wants to know how far, right? So if you remember, we had this equation, work equals the change in kinetic energy, and we want to fill in work equals 1/2 mass velocity squared final minus 1/2 mass velocity squared initial. Then again, we have a force and a distance, so we plug in force times distance for work. We'll do that. 1/2 mass velocity squared final minus 1/2 mass velocity squared initial. And then we get to plug in. So we have a force, 9,200 D, because it's going to be times, we'll just write it that way. And then 1/2, and then we have a mass of 570, and then increased from a stop position, so it wasn't moving, but then at the end it had a velocity of 20 squared. But then we want to remember, so initially it was a stop position. Again, we're going to multiply a 0 through here, so it's going to be 0, and then we just have to do our math. So 9,200 D, we just do the math, 570 times 0.5 times that by 20 times by 20. We get, let's do that one more time, 570 times 0.5 times 20 times 20, we get 114,000. Then we want to get rid of the force on this side and solve for D, so we'll divide both sides by 9200. Let's move that up. And then we're going to get 12.39, and we'll just say distance is 12.4 meters. And that's that. So that's how you do this one if you're given a force and you want to know distance. Hopefully that helps you, and let me know if you have any more questions.